At first glance, formulating a research question might seem like a straightforward step. Just decide what you want to study and go. But in truth, crafting a powerful research question is one of the most challenging and crucial parts of the scientific process. It's not just a starting point, it's a compass that guides your entire investigation. A well-constructed question doesn't just inspire curiosity, it defines direction, scope, feasibility, and even how your results will be interpreted. Imagine this. You're a student or researcher standing at the edge of a vast intellectual landscape. You could go anywhere, explore any problem, test any hypothesis, build any model, but without a clear, focused question, every path looks equally tempting or equally confusing. You might collect data without purpose, read aimlessly, or get stuck trying to boil the ocean. The solution: anchor yourself with a targeted, meaningful research question. One that is specific, answerable, and rooted in real gaps in knowledge. So, how exactly do you formulate such a question? One major step is to start broad, then narrow down. Begin with a general area of interest. Maybe you're fascinated by nanomaterials, cognitive psychology, or climate change. Next, immerse yourself in the literature. Read recent papers, follow debates, and notice what's still uncertain. Ask yourself, what are the limitations of current studies? Where do scholars disagree? What problems seem important but understudied? As you explore, you'll start spotting patterns and gaps. That's where potential questions live. For instance, suppose you're interested in renewable energy. A vague question like, how can we stop climate change, is too broad. But as you read, you might notice that while solar panels are improving, there's a lack of research on their performance in desert climates. Now you're getting closer. How does sand accumulation affect photovoltaic efficiency in arid environments? Suddenly, the question is specific, measurable, and grounded in real-world challenges. A strong research question often has these key characteristics. Focused, it targets a narrow aspect of a topic, not the entire field. Clear, it's written in straightforward, jargon-free language. Researchable, it can be answered with data. Qualitative, quantitative, experimental, or theoretical. Original, it addresses something not already fully resolved. Significant, it has implications, whether practical, theoretical, or both. Want to refine it further? Use frameworks. One popular approach is PICO, used in health sciences. Population, who or what are you studying? Intervention, what is being done? Comparison, is there a baseline or alternative? Outcome, what effect are you measuring? For social sciences or humanities, you might try the finer criteria. Feasible, interesting, novel, ethical, and relevant. You might ask, what's the difference between a topic and a research question? That's a crucial distinction. A topic is a general area, like artificial intelligence in education. A research question turns that into a problem to solve or a phenomenon to explore, such as, how does AI-driven personalized feedback influence student motivation in online learning environments? A great research question also anticipates the methodology. If you ask, what are the causes of urban inequality? You're setting yourself up for a sprawling, possibly unmanageable project. But if you ask, how do transportation infrastructure investments correlate with income segregation in U.S. cities from 2000 to 2020? You're pointing towards specific data, tools, and analysis techniques. Importantly, a good question should evolve. Many researchers start with one version and refine it as they learn more. That's not a failure, it's part of the process. In fact, the act of rewriting your question over time is a sign that your thinking is deepening and maturing. And what about students or early career scholars who feel intimidated by the process? The best advice is start asking questions constantly. Be curious, be skeptical, and don't be afraid to challenge existing ideas. Often the best questions come not from experts, but from fresh eyes, people who haven't yet accepted that something can't be done or is already known. Ultimately, learning how to formulate a research question is not just a skill, it's a mental discipline. It trains you to think critically, synthesize information, and seek clarity amid complexity. And once you master it, you'll find that your research flows more naturally. Your arguments become sharper and your contributions become clearer, not just to your peers, but to the world. Because in science and in life, everything meaningful begins with a question, and the right question can change everything. Formulating a research question is the foundational step in any scientific investigation. It transforms curiosity into a focused inquiry by defining the problem, space, scope, and intent of a study. The paradox lies in how a well-crafted question, just a single sentence, can determine the trajectory of months or years of research, while a precise question narrows down complexity, sets boundaries, and connects theory with experimentation, whereas poorly formulated questions lead to vague objectives and unproductive results. A general curiosity like, why do some materials conduct better than others, becomes a research question. How does the grain boundary orientation in nanocrystalline copper influence its electrical conductivity at room temperature? It's like entering a maze. If you do not clearly know what you are seeking, every turn feels equally uncertain. A good research question is specific, focused, researchable, significant, and feasible. It defines a gap in knowledge and outlines what needs to be explored, tested, or modeled. It must be narrow enough to answer through methodology, yet broad enough to contribute meaningfully to the field. Instead of asking, what causes cancer? A well-structured question would be, what role do specific microRNAs play in regulating apoptosis in triple-negative breast cancer cells? It's like aiming an arrow at a target. If the target is too far or too vague, you will not know if you have hit the mark. Formulating a research question involves iterative processes such as literature mapping, hypothesis generation, concept refinement, and peer consultation. The researcher moves from a broad topic of interest through progressive narrowing, asking what is unknown, why it matters, and how it can be investigated, using tools like concept maps, logic trees, or PICO frameworks to shape abstract ideas into empirical questions. In engineering, a broad interest in energy storage leads to, can defect-engineered 2D scenes improve capacitance in micro supercapacitors under high-frequency cycling? It's like sculpting from marble. You start with a block of curiosity and gradually chip away until the essential form of the question emerges. A research question often bridges disciplines and scales, requiring multi-scale, multidisciplinary thinking that incorporates physical, biological, computational, or social dimensions. In complexity science, emergent phenomena often defy single-discipline answers. So formulating a good question also involves understanding how broad or integrated the solution space should be. For instance, a project at the intersection of neuroscience and AI may ask, how can biologically inspired recurrent neural networks model adaptive motor learning observed in the cerebellum? It's like programming a drone to explore unknown terrain. You must define the zone to explore, but allow for adaptive navigation across disciplines. A research question is not only intellectual, it must be manageable within the constraints of time, resources, and expertise. Researchers must assess whether they have access to the necessary tools, collaborators, datasets, or methods. Questions should be ambitious yet actionable, balancing novelty with practical limitations, especially for early-stage researchers or student projects. Instead of a massive question like, can we simulate brain consciousness? A focused, feasible version would be, can EEG signals be classified using convolutional neural networks to detect sleep stages in real time? It's like climbing a mountain. You do not start with Everest if you only have sneakers and a day pack. Research questions emerge from a foundation of prior knowledge, revealing what is already known, where contradictions exist, and what theories or models can be tested. Good questions identify meaningful information gaps for the community, and tools such as literature reviews, citation maps, and meta-analyses help position the question within the existing knowledge landscape. For example, after reviewing conflicting results on enzyme kinetics in confined volumes, a researcher might ask, how does droplet confinement affect catalytic turnover rates of single enzymes compared to bulk solution? It's like being a detective. First, you gather all the clues. Only then do you ask the right question that leads to the mystery's solution. Learning to formulate good research questions is crucial not only for graduate students and early career scientists, but also for machine learning systems designed to explore science autonomously. In education, framing strong questions encourages critical thinking, hypothesis-driven inquiry, and academic independence, while in AI research, the ability to generate meaningful scientific questions is emerging as a benchmark of machine reasoning and creativity. In AI-assisted drug discovery, for instance, a system may suggest, can compounds with a specific 3D pharmacophore inhibit the same protein as known ligands with 2D similarity? A question that bridges chemistry and machine learning. It's like teaching an apprentice not just how to use tools, but how to choose which puzzle to solve in the first place. One of the hardest tasks is asking questions that are both original and ethical. Novelty requires pushing into unexplored territory, while ethics ensures the work benefits society and minimizes harm. Promising questions must sometimes be abandoned due to lack of feasibility, sensitivity, or ethical clarity, and the rise of generative AI further raises issues about authorship, bias, and responsibility in research formulation. For example, a question like, can we genetically edit neural circuits to enhance memory, must be examined through both scientific and bioethical lenses. It's like inventing a powerful engine. You must ask not only how fast it goes, but where it should take us and who it might leave behind. The future of scientific inquiry will depend on our ability to formulate more precise, integrative, and anticipatory questions. As interdisciplinary knowledge explodes, researchers will need to ask questions that cross scales and domains. From quantum biology to planetary ecosystems, AI systems may help synthesize literature, model unknowns, or even co-formulate questions with human partners, and the skill of crafting powerful research questions will remain central to the evolution of knowledge itself. Programs like Semantic Scholar and Elicit are already helping researchers refine questions by summarizing literature and suggesting unexplored areas. It's like upgrading from a flashlight to a spotlight. You can now see deeper into the forest of knowledge, but you still must choose where to shine the light